So the lesson is margin of error and confidence intervals. So polling an entire population is known as a census. Since it is impractical to perform this all the time, we take a sample from a larger population and use information from the sample to generalize about the larger population. This is known as an inferential statistic. Because the sample is part of the population, some amount of error will be introduced into the generalization we make about the larger population. To account for differences between sample statistics and population parameters, we use margin of error, which allows us to say with a specific degree of certainty that a data point from a population will likely fall between two values. This is known as a confidence interval, and it represents a range of values that a data point from the population is likely to lie between with a specific degree of certainty. Typically, statisticians, I can never say that word, use confidence intervals of 90, 95, and 99%. So, with confidence levels, each of the common confidence levels, we have a specific z-value that corresponds to them. Okay, so this is what we're going to have to use according to each of the formulas. So, this is the formula for confidence interval, and these are what each of the variables represent. X bar is the sample mean, z is the confidence level of the z-value, s is the sample standard deviation, and n is sample size. So it's basically just plugging into a formula. That's really all this procedure is. So let's go ahead and try the first one. So what we're going to do is we're going to go through and identify all the variables. So a poll of 218 randomly selected users of Facebook show that they are spending an average of 14 minutes per day on the site with a standard deviation of 3.1 minutes. Determine the range of minutes you could say that the population spends on Facebook with a 90% level of confidence. So, first thing we're going to identify is X bar, which is going to be the sample mean. So what's our sample average? Good. Our sample average is 14 minutes. Our z-value corresponds to the confidence level. So what's the confidence level? 90. So this is where we look at our chart, which says what z-value do we use for 90? Good. 1.645. And then the next one is S, which is our standard deviation, which is what? Good. 3.1. And then next would be our n value, which is the sample size, which is how many people were polled. Good. 218. So does everybody understand where I identified all those from? So now you set up your confidence interval, CI, and it's equal to your X bar, which is 14, plus or minus your Z value, times your standard deviation, divided by the square root of your sample size, n. And usually I'll simplify this side first. So this will be the confidence interval is equal to 14 plus or minus, and then I just do the math here, the square root of 218, 3.1 divided by it, and then times the 1.645. And when you do that math, it comes out to be, after you round to the hundredths place, 0.35. Now how you set up the confidence interval is this side here is going to be the minus version, because we have a plus or minus, less than, then we identify what the study is about, and then this side is going to be the plus one. So if we read through our question, a poll of 218 randomly selected users of Facebook showed that they spend an average of 14 minutes per day on the site with a standard deviation of 3.1 minutes. Determine the range of minutes that you could say the population spends on Facebook with a 90% confidence level. So what is this study about? How much time you spend on what? Good, so this is Facebook minutes. So in the middle you just identify what you're talking about, and then you just simplify each side of the confidence interval. So this comes out to be 3.65 is less than Facebook minutes, and then this side will be 14.35. So this is what the confidence interval looks like. So basically you can say with 90% certainty that Facebook minutes fall between these two values. What do you think? Easy, hard?
Can you just get the 0.35 from multiplying the 1.645 times it?
Exactly. So you can either multiply first or divide, it doesn't matter. But yeah, you basically, I usually do the 218 square root first, then I do 3.1 divided by that, then multiply it by the 1.645. Exactly. That's how you get the 3. Any other questions on it? It's really just like a plugging in the formula thing. We're going to do one more example together, and then you guys will have time for homework. So it says 350 students at Oviedo High School were randomly selected for a survey to determine an average amount of time spent completing homework each weeknight. From the survey, 200 students responded. The mean time reported was 52.5 minutes with a standard deviation of 5.1 minutes. Use the sample data to infer the range of minutes that an entire student body spends on homework each weeknight with 95% certainty. So we're going to go through and identify all of our variables. So X bar is going to be the mean, the average. So the mean time reported was 52.5. So that's your X bar. The next thing you're going to look for is your Z, which corresponds to the percent of confidence, which is 95%. But for Z, we don't use 95%. We have to look at our chart, which will give us a Z value. So what is the Z value for 95%? 1.96. Good. 1.96. Does everybody see where we got that from? Okay. And then the next is going to be S, which is our standard deviation, which is what? Very good. And then here's the one that is a little bit tricky here, your sample size. Anyone know what the sample size here is?
200.
Good. Why is it not the 350?
Those are
Good. So this is just one of those things we showed you an example of to make sure you don't make this mistake, because they'll throw in 2 numbers there to try to throw you off. But you only need the one that was actually what we used in the sample. So from here we'll set up our confidence interval, our CI. And our confidence interval is equal to X bar, 52.5, plus or minus Z, times S, over the square root of N, which is 200. When I do this math in my calculator, I'm going to end up with CI is equal to 52.5 plus or minus 0.71. Now we set up our interval. And this survey or this study was about homework time, right? Homework minutes spent. So homework minutes is going to go in the middle of your interval. And then on each side, you're going to do the math. So here, this side is going to be the minus. And when you subtract, it's going to be 51.79. And over here, this is going to be the plus, which is 53.21. So you can say with 95% certainty that the average homework minutes spent is between these two values for everybody surveyed.